So today we're looking at the arm structure and its relationship to functioning and living. And we'll start by looking at the bits. What do we call the arm structure, the anatomy of it? So there's the hands, all the joints of the hands, the lower arm. There are two bones of the lower arm. If you take your hand and feel that little knob and trace that up, that's this outside bone called the ulna. So feel it. And then the bone on the thumb side kind of gets lost in the flesh up here, but you can feel it down at the wrist on the thumb side. That's the radius. So and it's so interesting. There's you have 5 different bones of the fingers, and another set of 5, and another set of 5, and then we get 4 bones in the wrist, 3 bones, and then 2 bones. So then we come up from you feel that knob there that hooks around this flat part of the humerus, the upper arm bones, where you get hit a nerve in there and you feel hit your funny bone. This is the upper arm bone, and it comes up and makes a joint in the socket of the outside edge of the scapula or shoulder blade. And the shoulder blade is not attached to the torso. It's freely mobile. And we'll see some pictures of it in a minute. And then the shoulder blade makes a joint up top here with the collarbone. And this is kind of a locked together joint with a lot of connective tissue. And the collarbone makes a joint with the sternum. And that's a joint that has 360 degrees of motion. So the full structure is fingers and wrist bones and 2 lower arm, 1 upper arm bone, the scapula or the shoulder blade, and the collarbone. And that whole structure is the only place it's attached to the torso is where the collarbone meets the sternum. The shoulder blade is floating in a sea of muscle. It's freely mobile. So let's look at a couple of pictures of this to just get it even clearer. So here's a beautiful 1500s skeleton drawing by a guy named Albinus. And what I want to point out here is this arm structure is on the torso, attached in the skeleton as if the musculature was there. And look at the distance between the joint, where the upper arm is, and with the shoulder blade, the shoulder joint way down here, away from the ribs. Unlike the skeleton, where it's all just hung as if it's right next to it, we can see how sprung and suspended to the side the arm structure is, so that the arms can move freely while the elastic suspending spring of the ribs and breath mechanism can carry on. So the collarbone acts like a spreader, and it creates a support so you can use your hands. Not that many animals have collarbones. Dogs and cats don't, but raccoons do, for example. And here's the same. You just look at this whole beautiful drawing from the side and from the back. And again, you can see it's out to the side. The shoulder blade isn't down and back. Everything is sprung. You can almost feel the muscles that come from below supporting the shoulders out, and the muscles that hang from the top springing this out to the side. They are not heavy weights on us at all. And then here's a view from the top. So we're looking down. Here's a circle that shows the head. Here's the collarbone and the shoulder blade. Again, you can see the spacer action, like spreaders on a mast, suspending out the arm structure from the ribs. Another view of this, and I like this angle to really show this kind of leveraging of force. So it's like the collarbone goes like this, and the shoulder blades has a hook-like action, and if you pushed on your finger and this resists, you kind of feel like there's an arrow going sideways here. The direction of the arm structure, if you have to give it a thought, is sideways. It's not down and back, as many people are instructed. And this is important just to see it's the outside edge of the shoulder blade that opens up and becomes a socket. The levering of the arm is to the outside edge, to the shoulder blade here. It's not up into the neck and into the collarbone. And again, we can see how away from the torso the joint is. Here's the joint, and here, this is like a porte cochere hanging over the joint. The joint's happening here, and the collarbone, what we normally feel with the shoulder blade, is up and out into the side. Here's another angle looking straight on the joint. So this is the side of the body. Here's the outside edge of the shoulder blade. You can put your hand on that, and then here's the socket. So this is the armpit. What we feel is the armpit is right underneath the socket. And then the socket's right there, and then this goes to the front of the body, this process, and the wing, it's like the wings of the shoulder blade go front and back. Here's a back view. The spine of the shoulder blade is what we feel when we reach behind, but there's still a top corner of the shoulder blade very close to the back of your neck. It often has a little pressure point right around there. And now we've got the upper arm attached, the joint. And again, you can see that if you were that arm lifted up or was carrying something, the force is going through the shoulder blade. It's not going up here into the collarbone. And again, you can see that the thickness of the muscles of the bone where muscles are being pulled and forces are flowing. And this is an illustration in David Gordon's The Body Movable, a highly recommended anatomy book that shows the muscles we see in a muscle chart. Every one of them from here on the outer layer is an arm muscle. Look at this attachment coming from underneath. It's like a big, supported wings underneath for the arm, and then the trapezius from above, and the deltoids coming down and springing the arms from above. The glutes, of course, this is the leg muscle, but all of this that you see are arm muscles. The internal postural muscles that bring us into our activated spring are internal to this. So let's look at the significance of all these parts into action. And one way to feel it is what is the function of this? Why do we have an arm structure? And in a simple way of saying it, this limb here, this upper limb, is the limb to get the hands somewhere. All the range of motion and all its capability is about manipulating the world, doing something in the world with your hands. Without the need of doing something with your hands, we don't need a collarbone or a shoulder blade. The lower limb is the limb to move you in place, and it supports, it gets us to the places so the hand can work. And the head limb is the limb of perception. It's what the senses coming to you through there helps you navigate in the world and then do things with it. So our functional purpose helps us understand ways of scaffolding our directions to ourselves to either let ourselves move with ease or interfere with that. So knowing how it works and knowing the landmarks of it are really useful for this understanding, the use of it, what we're up to. And one way I like to take us through this functionally is if you were creating a robot or something. And so come to the side and let's act as if all we had were fingers, those 5 little limbs that are at the bottom. And all you could really functionally do is scratch, tap, you could do some stuff down there. But now I want to do more. So then I add a wrist, the 4 and bones and the 3 bones. And that gives me motion. Now I can flap really versus just tap and flap. But if I want to do something else, I'm going to have to add the next joint, which is the elbow. We looked at that. It's the ulna rotating around the upper arm bone. So now I can come up and come down. But I can't yet rotate. In order to rotate, I need to have those two bones we looked at, and the way this works, it's useful to know, is that the rotation is the ulna side, the pinky side stays stable, and the thumb side rotates around that side for free motion. If you line it up the other way around, you try to rotate around the thumb side, you end up with strain. You end up gripped. So there's an orientation that we'll even see the significance relating to the shoulder blades soon, but this hooks up with the ability of the hand to make a fist. So if you make a fist, notice a couple of interesting things. When you make a fist, there's a slight movement at the wrist. In order to make a fist, we need the wrist action. And what's happening here is the system is beautifully giving you power by making the muscles that are being activated be in a kind of a middle range. They're not overstretched and they're not overshortened. They're in the middle where they're strong. And so we get the slight compensation of the stretch in here is is made up by the little bend in the wrist. And so if you had to get take a knife out of someone's hand, you could hardly do it in this orientation, but all you do is tilt their wrist, make their wrist bend this way, and then there's no strength. Notice you can, if you had tried to pull your finger out, you can hardly, if it's here, you can pull it right out. So put your finger in, grab it, like a normal wrist, and then tilt, and notice how easy that is. So we'll relate that to something in a minute too. So the other important thing about the hand is you can feel as you make a fist, it's the pinky side comes in first. That side is the strength side of the hand. The part where there's the thumb and the opposing fingers is the fine manipulation side of the hand. So if we tend to grip a pencil really hard and try to do the fine movement from the outside, we end up getting into trouble. So there's so much about the hand right here, whether it's I'm reaching up for something, you can feel that it's the outside edge that's the strong side, connects to that strength of the ulna side and the ability of all this movement of the thumb and finger to manipulate things and be mobile. But so that's what we've already got, other than the hanging or something. If we have this much of the robot arm made, then if we want to touch more than just ourselves, we need to add another joint. So we add the upper arm, and that gives us rotation. We have a lot bigger of a rotation. This is the extent of the rotation I had without the top up shoulder joint. Now I've got, here's the upper arm rotating in the socket. So I have this joint and this. Now I've got this rotation in the socket. I actually now can come up to 90 degrees. I can do anything in this range under 90 degrees. And it's all happening here with the upper arm in the shoulder blade, that joint. But if I wanted to go above 90 degrees, then I need to recruit the next joint, which is where the collarbone meets the sternum. Then I can touch my ear and touch my tag and reach across. This gives me the full amazing range because the shoulder blade is free in a sea of muscles. The shoulder blade can go up and go up and can go around and can go behind if it's not caught on itself on the way it's hung. The shoulder blade can go behind, slide back. It can slide way forward and way up, all because it's supporting getting the hand farther in space. Just feel your own shoulder blade there moving. So as David Gorman likes to talk about this, it's like this is a collection of possibilities, and each of the next joints is recruited when we need it for action. So if all I need to do is scratch my leg, it doesn't make any sense to do that from the collarbone joint. But if I want to touch the tag behind me, I need that. If I want to put something up high, I need to recruit this joint. And interestingly enough, if I need to go even higher, then I recruit another joint, the joint of my toes. So I get to a certain range, and then I want to go further, other joints get recruited. So as a whole, it doesn't just end here, then the rest of me gets recruited as I have different things to do. So a couple of these, the way this motion and this order of things, it's a sequential order that each thing gets recruited one after the other as necessary. One of the ways we can tell if there's an interference is if we see something or feel something out of order. So I often work with conductors, and I see a lot of this where the conducting is happening from the upper arm. Move your arm and initiate from the upper arm. And over time, that creates a lot of tension in the neck and shoulders. Whereas if I do the conduct, or I do a pattern, I'm moving in space here. If I'm just sort of the same, but I'm doing it because I'm touching in space, then my joints get recruited when necessary, but I'm not lifting my arms up and down. If I'm going to, so the way, it makes sense for certain ways conducting has been taught, but if I can scaffold the teaching, for example, so that I'm touching in space, I'm not teaching someone a pattern of movement by telling them to move their arm. It's the same thing on a violin or an instrument. If I've been told to do something with my arm, I often end up seeing a lot of shoulder, upper arm movement versus if I've got a sense of what I want, the bow on the string. Same thing with moving. If I'm not thinking about where I'm touching the batons, the mallets, I can end up doing it from my arms. So from my upper arm. So I'm out of sequence. Something is initiating back here where really it's something that's happening at the fingertip end first. So we ignite that when we're attending to the task at hand. And that's what we're doing, whether it's in movement or playing an instrument or doing a job cutting the carrots. If I do it from my upper arm, if I move things from the upper, something is pulling me out of sequence. And there are many things that can do it. The way I learned it, or if I'm a little bit in a rush, or other ways that I might organize myself to pull myself out of sequence. So another part of this that's a kind of a beautiful thing too to be able to tell. So one of them is what sequence am I in? Am I feeling strain in my shoulders and upper arm? Very often that's because I'm actually doing the movement in the wrong sequence, in a sequence that creates that sensation. Change something and you'll get it become easy. The same thing here, if there's this interesting thing that most of what we do is in this, with our hands, is in a range in front of us. And I could take an object in my hand and I can go to a range that's comfortable. We just sort of can tell, like, oh, I can hold this and I'm not strained. But if I go further, so now my shoulder blades are pulled in front and my collarbone is pulled forward, which is really the only reason I want that range is actually to meet something behind me. It's not really the range I need for something forward. This is just like the wrist example. This is like as if I'm working and I'm in this thing. There's no strength. Some things are overstretched and some things are shortened, which is a weak orientation, and we literally can feel that. Whereas if I'm in the range where the musculature in the front and the back are relatively in their middle range of length, then I've got lots of power here. And I find this incredibly important because often when, let's say we're going to put something down on a table or hand something to another person, we get this far. People often do this, do a reach to get at the other part, and there's all this strain and effort where really that's the moment. I get this far, now I need to recruit another joint. I either need to bend or I need to take a step so that when I hand something to someone, I'm in that comfortable range, I'm not in the reach. Same thing, I might be putting something onto the ground. I get just about here, and people often then go into that strain distance where really I just keep recruiting joints. So that when I have an object in my hand, I feel it in this range where if it was a heavy weight, I would have it there, versus constantly being in this orientation where the arms are pulled further from us than where they're really supported by the ground and the rest of our system. So understanding both the reason for the arm structure here and having the sensory feedback so you can tell when you're initiating from the shoulder end first compared to initiating from intention, having something to do, and being able to tell when you're in a range that's comfortable versus a range that you couldn't sustain. You can then just make shifts so that what you're doing doesn't over a day create what people think they have, shoulder tension. Actually, they've just been working in such a way that this area has had to work harder than it needs to, depending on how you organize it, to do the task of life. So learning about this is one of the beautiful underpinnings of freedom. And the last piece that seems very important in our culture is that so many people have been given instructions about how to place their shoulders. And so somebody walks around at a certain stage of life in 7th grade here, they're looking at their cell phone, and somebody sees them from the outside and thinks their shoulders are curled over. This isn't a shoulder problem. This is a person is compressed, and their axial skeleton is actually compressing, and the arm structure just follows that. Everything's shut down a little. But if I can stimulate, like, hey, catch a ball, hey, look up, wave, all of a sudden the person comes into full dimension and their arm structure is where it can be, it needs to be. If I have for a long time stayed in compression, it can certainly help to do movements that give the person back their full range. But if I'm here and then I'm told to pull my shoulders back, sometimes that'll bring someone up, but it often creates an incredible amount of effort and fighting against ourselves. So when we're positioning, and this would be the same, you can see this, if I'm standing up and I think, oh, it's got to be good to pull my shoulders back and down, that's like really a good position to be in, but now I want to do something in the front of me, I'm going to have shoulder tension. I would say 75% of the people I work with who have, quote, shoulder tension is because they've been positioning their shoulders. Whereas that movement of the shoulder blade back and down is the movement of reaching behind me. So I'm putting my shoulder blades in the orientation of reaching behind me, and then I'm trying to do things in the world. I'm literally fighting myself, which is a definition of effort, fighting your own self. So we, in this work, utilize the freedom of this huge range. Like the range, if you drew it, it's huge of what the arm structure can do, both in the horizontal plane, all just from the collarbone area. I don't want to be limiting that by positioning my shoulders. They're not a thing. If you could go for a week without even using the word shoulder, let yourself have free arm structure that does things and have an attunement to the sensory information to let you know if you're out of order or if you're pulled forward and straining rather than balanced. This will be a huge step toward being able to function and do things in the world, manipulate the world with your hands, and doing that with freedom and ease and power and not injury. This is a huge segment on injury prevention. Okay, I hope that's helpful to you. Okay, I hope